Find the range of values of a for which the equation 3x square plus ax plus 3 will have two real roots, one repeated root, and non-real roots. Okay. Now, whatever is the nature of the roots, it is found by b square minus 4ac, right? यहाँ पे b का value a है. Okay, the constant x2 के coefficient a is 3 and the constant term is 3. So b square minus 4ac यहाँ पे कितना हो जाएगा? b square minus 4ac यहाँ पे हो जाएगा a square minus 4 into 3 into 3. 4 3 is 12, 12 3 is 36. So a square minus 36. This is b square minus 4ac. Okay. Now we look at the question separately. The first question is two real roots. Okay, roots are real when discriminant is basically greater than 0. So for the first question, we simply put delta greater than 0. Okay, so I'll just write it at the top. Okay, a square minus 36 हो जाएगा delta का value. Okay, so for two real roots, basically it is a square minus 36 being greater than 0. Okay, or a square being greater than 6 squares. Guys, ये तब होगा when a is greater than 6, of course, and also a should be less than minus 6, right? To take any value less than minus 6 and square it, okay, uska square 36 से ज़्यादा ही होगा, right? Okay, so for the first case, two real roots, a should be less than minus 6 and a should be greater than 6. Okay, we'll learn this in functions आगे जाके. Okay, how to write this? Minus 8 minus infinity to minus 6 union 6 to infinity. Okay, all open intervals, non-inclusive. Okay, one repeated root. Okay, roots are repeated when discriminant is equal to 0. Okay, so a square should be equal to 36. Okay, or a should be equal to plus or minus 6. That is the second question ka answer. Third question, non-real roots. The roots are non-real when the discriminant is less than 0. Right, so if a square minus 36 is less than 0, a square should be less than 36. That means a is lying between minus 6 and 6, both non-inclusive. Okay, in functions, we'll see the sort of sophisticated way of writing this is minus 6 to 6. Okay, let's go on to next question. We'll again come to this question when we study the functions and higher order equations, nature of graph. Okay, where we'll see something called as the Wavy curve method. Okay, there we'll see how to tackle such questions जहाँ पे range की बात आती है. Okay, that you can learn, that you can do very quickly once you understand the Wavy curve method. Okay, let's go on further to the next question. Given f1 equals to x and f2 equals to x square plus 11x plus n, then find the number of possible non-negative integral solutions for n such that f1 is equal to f2 will have real roots. Okay, the first condition is that f1 is equal to f2 will have real roots. Okay, f1 क्या है? Equals to x. f2 क्या है? x square plus 11x plus n. Okay, we equate them, right? Okay, this particular case, okay, f1 is equal to f2 will have real roots. Okay, so if you solve this, you will get x square plus 10x plus n should be equal to 0. This equation should have real roots. When does the quadratic equation have real roots? Whenever b square minus 4ac is greater than or equal to 0, right? So here b is 10, a is 1 and c is n. So b square is 10 square minus 4 into a is 1, c is n should be greater than equal to 0, or basically 100 minus 4n should be greater than equal to 0. Okay, guys, this will happen when, okay, I'll take it here, when 4n should be less than equal to 100, right? Or n should be less than equal to 25. Okay, so बहुत लोग क्या करते हैं कि how many possible non-negative integral solutions बोला है. Okay, they directly say the answer is 25 solutions exist, but the answer is not correct. Okay, why? Since they are saying non-negative. Okay, non-negative मतलब negative नहीं हो सकता, तो zero भी आ सकता है अपने आंसर में, right? So if n is less than equal to 25 here in this case, n can take any value from 0, 1, 2, 3 integer values 0, 1, 2, 3, 4 up to 25. These are not 25, these are 26 values. Okay, so the answer is there can be 26 possible values of n. Ram and Sham are writing a quadratic equation. However, Ram copies the wrong constant term and obtains the roots as 1 and 7. Similarly, Sham copies the wrong coefficient of x and gets the root as 4 and 3. Find the actual roots. Okay. Now it's a very conceptual and a very important question to discuss because इससे काफी कुछ चीजें हमारे सामने clear हो जाएगी. Let's suppose I'm writing a quadratic equation, okay, having roots 2 and 3. Suppose. So that equation will be x square minus sum of the roots into x plus product is equal to 0. The roots are 2 and 3, right, guys? Okay. Now suppose I change the constant term. Okay, I suppose change the constant term. I write x square minus 5x plus 4 is equal to 0. Suppose. Okay, so let's find out the roots of this quadratic. X square minus 5x plus 4 equal to 0. दो नंबर जिनका सम -5 हो, प्रोडक्ट 4 हो, कौन से होंगे? -4 -1, change the sign, 4 and 1. Okay, if you observe, although the two equations have different roots, but since the constant term has been replaced, the two will have the same sum of the roots, right? देखो इनका भी sum कितना है roots का 2 plus 3 which is 5, right? इसका भी sum of roots कितना है basically 5. Okay, so basically if you're copying out a quadratic equation and if you copy the wrong constant term, okay, you can still obtain the correct sum of the roots, right? So if Ram is copying the wrong constant term, okay, he obtains the roots as 1 and 7. That means from here, very easily you can say sum of the roots will simply be equal to 1 plus 7, which is 8. Okay, although these two are not the correct roots, I know. Okay, but from this concept, we have understood that whenever you replace the constant term, okay, the coefficient of x is still the same, and hence the sum of the roots will still be same. Okay, by the same logic, guys, if you suppose write x square minus 5x plus 6 is equal to 0, okay, in this case, suppose I replace, okay, suppose I replace here the coefficient of x here. I write x square plus x, okay. Suppose I write here x square minus 7x plus 6 equal to 0. Okay, now I have changed the coefficient of x here in this case, right? Okay, but the constant term is plus 6 in both the cases. Okay, what do you observe? The product of roots is basically 6 upon 1, 6 upon 1 in both the cases. So for both the cases, the product of the roots is basically same, right? So although you have copied the wrong x coefficient, you can still obtain the correct product of the roots, right, guys? So in this case, since Sham copies the wrong coefficient of x, he gets the roots as 4 and 12. Okay, you can very correctly find the product of the roots. The product of the roots will be 4 3s are 12, right? So now you have the correct sum, you have the correct product of the roots. The actual correct equation will be x square minus sum into x plus the product is equal to 0, right? So what are the actual roots? Two numbers whose product is 12 and sum is minus 8. 6 and 2, negate the signs. That is the required answer. Okay, so I guess that's it, and I'll see you in the next class where we'll continue with polynomials and higher order equations. So let's meet next time. Bye bye.